Okay, you just start with our lecture. Fact number three, that is, when GCD of A and B are 1, we can say A and B are relatively prime. These are our Euclidean algorithm. If you have two elements A and B, and you have to find out the remainder or GCD of A and B. So in that case, if you divide each and every element, if you say the after dividing this A with you can say you will finally first you will get r, then say you have two element, this is r, and this is we call it as r2. Then we divide these and write it remainder, and the same from here you can at every time you have to place r over here, and from remainder r2. In that case, you repeatedly apply this step, same step, and until you will get 0 over here remainder. In that case, the last element will be your GCD of A and B, and this is one of the pseudo code for this Euclidean algorithm. So let us give you one example, basically two examples, but you have to solve this one example by your own. Find the greatest common divisor of 2740 and 1760. If you can see, the GCD is 20, like say R1 is this and R2 is this. If you divided it by if you divide this element, divide 1760, if you divide 2740 with 1760, the remainder is 980 and the quotient is 1. In that case, you will get remainder this. You place this element over here and this over here, then divide 1760 with 980. The remainder is like this one, and the quotient is 1. Then you place 789 and 980 over here as a q1, and this is as a q2, and this then divide, the divided it by, you will get 200 as a remainder, is quotient is again 1. So in that case, 780 is placed over here, and then 200 is placed over here. In that case, you have to in that case, quotient is 3 and remainder is 180. In that, similarly, you will apply the same procedure until you will get 0 as a remainder. Say you get 0 as a remainder, then you place this 20, which is R2 over here. This will be our basically the GCD of basically the uh, 2740 and 1760, the GCD of these two numbers. Similarly, you will perform find the GCD of two, 225 and 60. In that similar step as we perform in the example 7, you will get the GCD of these two numbers will be 5. So this is a extended Euclidean algorithm. I am not going to what you call the give you the explanation about this. You have to do it by your own self. But this is just the extension of a Euclidean algorithm. And kindly solve these two examples, example number 9 and 10 by yourself. So uh, these are also one linear congruent classes, linear congruence classes. I mean to say, if you have you have one equation, y is equal to mx plus c. It is one equation in one linearly one dependent and one independent variable. So we will discuss the same things in congruence classes. Basically, the cryptography uh, often involves solving an equation or set of equation of one or more variable with coefficient in set of integers. And this section we will basically see how one can solve the single variable linear equation and set of linear equation in congruent classes like this one. So single variable linear classes, I mean to say it is about like this one like say this one. Equation is of the form ax equal to congruent to b mod n. Might have no solution or limited number of solution, assuming that the GCD of A and this n is D. If D does not divide B, that is GCD of A and n does not divide B, then there is no solution to this congruent uh, equation in single variable. If D divides B, D divides B, then there are D solution to this equation. Let us take one example like this one. Solve the equation 10x congruent to 2 mod 15. So in that case, first of all, we have to calculate the GCD of A with 15, which is 5. Since 5 does not divide 2, in that case, we have no solution to this congruent class under mod 15. Let us take another example, like in previous, like solve the equation 14x is congruent to 12 mod 18. So in that case, if you can look over here, 14x is congruent to 12 mod 18 can be written as 17x is congruent to 6 mod n, and the x is congruent to 6 times inverse of if you can apply both sides in inverse of 7, then here we will get say, x, and the inverse will be applied on other side. In that case, if you can look over here, the inverse of 7 under mod 9 is 4. In that case, we have 6 as a what you call it as a solution. Though, so in that case, the student, the this will be x naught. The then the x1 is x naught plus 1 time 18 divided by 2. In that case, the solution to this equation is 15. So uh, you have to solve this example by yourself. This equation, how this we can calculate the uh, what you call the solution of this congruent equation. So set of you can also solve the system or equation with same modulus if the matrix formed from the coefficient of the variable is invertible. So if I just talk about only previously in previous slide, I just talk about uh, uh, congruent equation in one linearly independent variable, but here we are talking about set of linear equation under modulo classes. In that case, these are system of equation. This can be written as a matrix form, and this is these x column vector which is given over here, x1 x2 up to xn, which are element of Rn, and which in that case particularly over here, the if I can say these are the element of z z zn Zn. So individually, but if I can say these are the, it is in tuple, so it can be, I can say this is element of Z n of n, Zn of n. So I want to calculate, I just multiply the inverse of this matrix over here. In that case, I will get the x1, x2, xn, which are the solution of this equation. So if I just give you one example how one can solve this system of linear equation in modular classes. So let us say this one. They solve the system of following three equation in same modulo class. So the result is x is congruent to 1 mod 16, or y can be y is congruent to 4 mod 16, and z is congruent to 14 mod 6. We can check the answer by inserting these an equation, and we can say these are the basically the solution of this system of congruent equation. So in that case, dear student, we are talking about the same modular. If the modulars uh, are not same, in that case, the problem will be quite complex. Because here, if you can look over here, we are just solving these equation in under modulo 16. But if we can say we just solve this in under modulo P, under modulo Q, and under modulo R, in that case, dear student, our problem will be quite complex, and we have to solve our very complex problem into a very simplest problem. In that case, this is quite complex way to find the solution of this by hit and try method. So there must be some mechanism that can easily answer this type of solution to these type of equations. So in that case, dear student, we will study in our next few lecture the CRT, Chinese remainder theorem. So this is the basically the idea how you can solve your system of equation like this one through Chinese remainder theorem with different under different modulo class. So till then, dear student, today is our lecture about some basics of arithmetics, and these are some source of my lecture. I have just take some help from these sources. So till then, thank you all, and please stay at home. And if you have any problem regarding my lecture, do ask me. Allah Hafiz.